Hello everyone! We want to discuss a topic about implementation of category theory in logical networks and their usage in solving of morphological tasks. The main problem of this topic is to develop methods of building logical networks so that they automatically solve any system of equation of predicate algebra. Can be done by a person using the formulas of predicate algebra. And we know that the universal mathematical apparatus of the algebra of predicates is proposed, and more precisely is its certain fragment, which refers to the description of logical spaces, logical analysis.
We want to talk a little bit about category theory. This is an important part of our topic. Category theory solves solely internally mathematical problems, and this is a direct output of category theory to the task of software development automation. Category theory offers a special way of studying objects. There are basically two ways to study the structure of an object. One is to dissect its internal content to determine the composition and structure of the parts that make up this object. Another indirect method is to design this object to some set of related objects and make a judgment about the internal structure of the object by properties projections. In fact, the last method, which formalizes within the framework of category theory, seems to be feasible for a complexly organized object. And we also want to talk about another topic, predicate algebra. Predicate algebra claims to be a universal mathematical tool for the formal description of information processes. This tool is fully accessible to information system developers for practical applications in improving artificial intelligence. The basis of brain-like hardware and software complexes are logical networks, which in turn are a schematic implementation of predicates algebra formulas which describe algebraic structures.
So in a category theory, it is essentially the same algebra of predicates. And how you can see the difference between the category theory and the predicate algebra lies only in the fact that the first moves from top to bottom, made at knowing the higher logical mechanism, and therefore uses as a starting point the record level of community. The second, moving from the needs of informatization, moves in the study of the same logic of thinking from the bottom up.
When we talk about logical network, we talk about the system that can solve the system of equations given by an appropriate model. And the main task is to develop such methods for constructing logical networks. So in future, these networks will automatically solve any system of equations of the predicate algebra as smoothly as a person can do, using formulas of the algebra of predicates. If you operate with formulas, it is possible to solve any system of equations of predicate algebra that characterizes a given model. As you can see on the picture, we show a conceptual model of multi-threading network solution. This network is solved by using threads. Each thread is tied to a specific pole and intersects all related branches of the pole on the subtable of the relationship table for the branches. In the process of intersection, many intersections are created on the basis of the table of relations of the branch. The state is connected with the flow of the pole, after which logical multiplication is made between the non-digit of the intersection, the set of the state of the intersecting pole. The result is written in the state of the pole. The process of synchronization of threads takes place only those threads of which state of poles have changed since the last run of threads are started. If no one of the pole threads is changed, all threads are held.
The problem of solving a system of predicate equations can be described as follows on the picture that you can see on the screen. First, we set the initial values of some poles. First, we determine the branches along which the movement of information will take place. These branches determine the names of the equations that need to be solved in this measure. In order for the information to go to all adjacent poles, it's necessary to determine the branches incident to the active poles on a common network graphs or table of branches. Second, in order to solve the equations, we need to convert the set of values on the first half circle of this measure. To do this, subtitle all contained in the active pole data into the equations expressed by the ratio. Third, we defined the set of the all poles adjacent to the active. Fourth, in the second half circle, we determine the value of each adjacent pole. Fifth, check if the stability criterion is reached for each new value of the pool obtained of this measure. There is an old value of this pool and this value match. Sixth, all the pools that we filled of this measure become active for next measure. All other poles cease to be active. Seventh, I'll go to the next measure, point 1.
As a result, the developed logical network allows us to reduce the area of change for intermediate variables and also extend the coverage of morphological problems modeled by logical networks.
Thank you for your attention.